In this video lecture, I will explain context-free grammar. So what is context-free grammar? A context-free grammar G is a quadruple having four components V, T, P and S, where V is a set of variable or non-terminals, T is a set of terminals, P is set of productions and S is a start symbol. So here we say non-terminal. So all capital letters will be a non-terminal and small letter symbols and digits, that will be terminal. So now the production will be in this form: A to alpha, where alpha belongs to V union T star and A belongs to V, and the symbol epsilon indicate null string. So what does it mean? When I say A to alpha, that means there is only one symbol and we are saying A belongs to V. That means this A should be some non-terminal. So here the left hand side of the production, that is A, it should be a single non-terminal. That means there is only one symbol A on the left hand side of the production and that symbol must be a non-terminal. And here right hand side of the production is alpha, and where alpha belongs to V union T star. So when I say star, that means it includes null string also. So null string is nothing but epsilon. Okay, so when I say the right hand side of the production is alpha, so and alpha belongs to V union T star, that implies that right hand side of the production, it contains the string, and that string can contain any number of terminals as well as non-terminal including null string, because here it is non-terminal union terminal. So that means it can be a combination of terminal and non-terminal, and since we have put star here, so including null string. So the first thing is what? The left hand side of the production should be a single non-terminal. So there will be one non-terminal, single non-terminal in the left hand side of the production, and right hand side can be a combination of terminal and non-terminal including null string. So these two points we have to keep in mind. And CFG, we also call it type 2 grammar. Okay, so this is also called as type 2 grammar. So this is type 2 grammar, and the language generated from this grammar is called as type 2 language. So this is type 2 grammar, and we say the language generated from this grammar is type 2 language, type 2 language or context free language, CFL. Okay. So now let's take one example. Here G is a grammar that has four tuples V, T, P and S, and here we are saying V is capital S, T is small a and small b, and these are the set of productions, and S is the start symbol. Okay, so here see, we can left all the production we can see here in the left hand side of the production we have single non-terminal S. So this is one production, S2 ASA, S2 BSB and S2 epsilon. So instead of writing three production, we can just put a slash and we can write in a single line also. Okay, so here you can see in all the production, the left hand side of the production, it contains single non-terminal because it is defined here, this capital S is a non-terminal, and right hand side of the production, it is a combination of terminal and non-terminal. So here small a is a terminal and capital S is a non-terminal. So this is a right hand side of the production is combination of terminal, non-terminal and terminal. Then here terminal, non-terminal, terminal, and even I can have null string or epsilon in the right hand side of the production. So this is the example of CFG, and we know that a grammar is used to generate the language. Now if this particular grammar is given to us and if it is asked what is the language generated by the grammar, so for that what we should do, we should use these production and we should derive the string and some at least 3 to 4 string we should derive from the given grammar, and we should see the pattern, and based on the pattern we'll come to a conclusion that okay, this is the language generated by the grammar. Okay, so let's take one example. Same example, what grammar is given to us, and here we have to tell what is the language generated by this grammar. So what we should do, we should try to derive the string, different valid string of this grammar. Okay, so now if I say, and we say that S is a start symbol, so whenever we derive a string we should always start with the start symbol. So S to ASA is one production, S to BSB is another production, and S to epsilon. So any one I can use. So suppose I have used S to ASA. And now what we should do in derivation, we should replace non-terminal by the production, because for each non-terminal we will be having one production. So ASA, now instead of this S I can write either ASA again, or I can write BSB, or I can write epsilon. So suppose I replace again this S by ASA only, and then this becomes AASAA. Again this S I replace by ASA only, so this will become AAASAAA, and somewhere we have to stop it, so there will be some terminating condition. So terminating condition will be some terminal symbol will be having for the non terminal, or some or epsilon we will be having. So now at the end S is replaced by epsilon, so it will be 3A here and 3A here, so it will be AAA. Okay, so this is one of the string. Same way we can try with a different production, and we will see what different string we are going to derive from this. So now if I take BSB, so now next time for S I can either write ASA, or I can write BSB, or I can write epsilon. Suppose we take BSB only, so this will be the string BB SBB, and then again this S we will replace by BSB only. So now we will get BBB SBBB, and again this S we replace we can replace by BSB only, or we can just stop it here itself and we replace this S by epsilon. So we get this. So here we got 6 B's. Okay, so now with this I cannot conclude anything, so we'll try to generate some other string, and we will see, because we need to find the pattern. So now S to epsilon is also one string. Okay, and then what I do, S to ASA I will do, and then next step I'll replace this S by BSB, and then next step this S by ASA. Okay, and then next step S by epsilon. So I get ABA. And now if I say BSB I use, and the next step instead of replacing S by BSB I replace by ASA only, and then I replace S by epsilon. So you can see here I get BA, and here I got AB. So if I say this is W, so this is what the reverse of that WR. So same thing will be applicable for all the string. This is W, so WR will also be definitely same thing only we are going to get here. This is W, so WR will also be same BBB. This is WABA, WR will be ABA only. If it is BA, it will be AB. So we have got the pattern now. So we'll say the language is WWR, where W belongs to AB star. Why AB star? Because S to epsilon is also there. So epsilon is also a valid string. So then we will say it is AB star. So this the language generated by this grammar will be WWR, where W belongs to AB star. Okay, now this is a non-regular language. This is a context-free language. Why non-regular language? Because I cannot construct finite automata for this. Okay, so now if it is a regular language, I have finite automata for that, and I have a regular grammar. If it is a context-free language, what is the machine for that? Machine is PDA, and the grammar is context-free grammar. Okay, so hope you have understood the concept of context-free grammar. Thank you for watching.